Hi, Assalamualaikum warahmatullahi wabarakatuh. In this video, I'm going to give more examples related to how you can determine whether the set of given vectors is linearly independent or linearly dependent. Well, recall that in the previous video, we have looked at the idea of linearly dependent and linearly independent. And we have done one practical example related to that. And so in this video, we're going to look at more examples for determining whether the set of vectors is linearly independent or otherwise. Okay, so here is a simple example. Well, it says here we have a set of two vectors. So this is the first vector and this is the second vector. And you can see clearly that the vectors here are combined in this way, such that the result here is 0 vector. So here is 0 vector. This is the second vector, and this is the first vector. And notice that right next to it here is our first scalar. So that one is C1 is -2. And for this one here, although it is not written, but we all know that the value of the second scalar here is equal to 1. And since what we have here is non-trivial solution, that means we don't get all zeros as our answers. Therefore, we can say that the set here is linearly dependent. Okay. Now, in a similar way, you can see that this is also linearly dependent because, well, you can see 2 times 1 is 2, -5 times 0 is 0. So 2 minus 2, we get 0. So we have a set of scalars. For example, we have C1 equals to 2, C2 is -5, and C3 is equal to 1. And again, this is non-trivial solutions. Therefore, the set of vectors here is linearly dependent. So you decide based on the values of your scalars. Okay. Here is the last example. Well, here we have scalar 1. So C1 here is 1. And then scalar 2 is 0. And this is also non-trivial solution. Okay, which means that we have at least one answer here or one solution here is non-zero. Okay, so we have at least one answer given here is non-zero, which is this one. Okay, so at least one. Okay, right. Now let's move on to examples that are a bit more practical, examples that require us to do a bit of calculations and reducing the matrix to a simple form using elementary row operations. Okay, and we have 3 different questions, and I'm going to start off with question A. We're going to determine whether the given set of vectors here are linearly dependent or otherwise. So we're going to start off with understanding that the starting point of answering this question is by coming up with this structure. Okay, so this is what we have to do first, and here we have C1 is 1 2 3 1 factor 1, C2 2 2 1 3. Well, C3 is -1, 2, 7, -3, and here is all zeros. So this is a homogeneous system of linear equations. And in order to find what values are for C1, C2, C3, what we can do is we can represent the whole thing here in using augmented matrix. So we have 1, 2, 3, 1. Okay, and -1, 2, 7, -3. So here we have 0, 0, 0, 0. Okay, so what we can do is I'm going to well, change this part into 0. So the operation that I need to do is R2 plus negative 2 R1. So for the first row is maintained as it is. For the second row, it will be 2 minus 2 is 0. 2 minus 4 is negative 2. Next is 2 plus negative 1 times negative 2. So 2 plus 2 is 4. So here is 0. 0 plus negative 2 times 0 is 0. Okay. Also, I need to change this part to be 0 as well. And since the third row is still, you know, empty without any sort of changes, we're going to like do the process straight away. Okay, so here I'm going to also change the third row so that this part here becomes 0. So we have this process that you can consider. So 3 plus negative 3 times 1 is 0. 1 minus 6 is negative 5. 7 plus 3 is 10. 0 plus negative 3 times 0 is 0. So here is a bit easy for this part here. Okay. Also, this part should be changed to 0 as well. And therefore, I'm going to do the whole change for the last row. And in order to change this to 0, I shall consider this operation R4 plus negative 1, R1. So 1 plus 1 times negative 1 is 0. 3 minus 2 is 1. Negative 3 plus 1 is negative 2. Here is going to be 0. Okay, so what else? Next is what I need to do is I need to switch the position, because clearly you can see that for this part, let me just change the color. Okay, so here we can see that this is already 1. This row is already 1, so it would be nice if we, you know, change the position of these two rows. Well, that's what I'm going to do. So I'm going to change the position of the second row with the fourth row. Here we have 1, 2, negative 1, 0, 0, 1, negative 2, 0, 0, negative 5, 10, 0, 0, negative 2, 4, 0. So next, what I can do is, do I have space? Okay, I have space here. Well, I'm just going to continue on the next page. What I'm going to do next is I'm going to change this to be 0. Okay, so the operation that I will consider is row 3 plus, so we have row 3 plus 5 times with the, is it second row? Yeah, second row. Okay, so this is the operation that I will consider, and this operation will give the following result. 1 to negative 1, 0, 1 to negative 1, 0. The second row is 0, 1, negative 2, 0, 1, negative 2, 0. So what happened here is 0, 0. So negative 5 plus 5 is going to be 0. So here 0, 0. Next, 10 with negative 2, 5. So 10 minus 10 is 0. And here is also 0. Okay. And notice that I also need to change this part to be 0. So the operation that I will consider is the change of row 4 plus 2 row 2. Okay, so by doing that, I will get, this one is 0 and 0. Okay, so 0 and 0. And here we will have 4 plus negative 2 times 2. So 4 minus 4 is 0, and here is also 0. So that is the simplified form of our augmented matrix. Yeah, and based on that, what I can do next is, well, we have this part to consider. So basically it says 0 times c1 plus 1 times c2 plus negative 2 times c3 is equal to 0. Therefore c2 is equal to 2 times c3. Now that is the first equation. You can notice that we have two equations to be considered, but we have three variables or unknown to be solved, and therefore we know that there will be one free variable. So in this case, we're going to let c3 equals to t, where t can actually be any real number. Okay, so that's the solution. C3 is equal to t, so that's the solution for C3. Therefore C2 is equal to 2C3, which is equal to 2 times with t. So that's the solution for the value of C2. Next, if you consider this part here, it basically says that we have 1 times C1 plus 2 times C2 plus negative 1 times C3 is equal to 0. Therefore, C1 is equal to C3 minus 2C2, which is equal to, what is C3? C3 is T minus 2. C2 is 2 times T. So this becomes T minus 4T. Therefore, C1 is just negative 3T. And because of that, clearly we have a solution that is non-trivial. We have, it could be like T can be any value. For example, if T is, if T is 1, so we have like 1, C2 is 2, and then here is negative 3. So we can have a solution that is non-trivial, in other words. Yeah, therefore based on that, we can conclude that the set of vectors given here is linearly dependent. Okay, right. Now we're going to look at the last example here. So this is the last example that I'm going to talk about in this video. For this one here, I think you can try and do it on your own. So I'm just going to move straight to this last example here. Okay. Hang on, let me just erase everything. So here we have this example where there are three vectors here. So again, the starting point would be C1 vector 1 plus C2 vector 2 plus C3 vector 3 is equal to 0 vector. So here we have C1, the first vector is 1, 2, 0, plus C2, second vector is 1, 1, negative 1, plus C3, 1, 4, 2, this is equal to 0, 0, 0. And in order to solve this system of linear equation, you can represent everything here in augmented matrix. Therefore, we have 1, 2, 0, 1, 1, negative 1, 1, 4, 2, 0, 0, 0. So, well, I'm going to start off with exchanging the second row and the third row. So that's my starting point. 1, 1, 1, 0. So the third row is at this position now. Second row goes down. Okay. Right. Next, what I'm going to do is I'm going to consider, well, turning this into 0. So how to do that is I'm going to consider this operation. The third row will be changed. by this operation here, we will have R3 plus negative 2 R1. Okay, so here I will have 1, 1, 1, 0, 0, negative 1, 2, 0. So for this part here, 2 plus negative 2 is 0, 1 minus 2, negative 1, 4 minus 2 is 2, this is 0. Next, what I can see is, well, we have similar values for the second row and the third row. Well, what I can do is I can let this be first let this be equal to 1. So how to change that is I'm going to multiply negative 1 with the second row. So 1, 1, 1, 0. Here we have 0, 1, negative 2, 0, and at the bottom is 0, negative 1, 2, 0. Okay, now what I can do is I'm going to let this become 0. So I need to consider this process of changing the third row plus 1 times R2. Okay, so this one plus with 1 times R2. Therefore, what I will get is 1110, 1110. For the second row is 0, 1, negative 2, 0. And for the last row, it becomes 0, 0. So that one is 0. And of course, negative 1 plus 1 is 0. And here is 2 plus negative 2, sorry, 2 plus negative 2 times 1 is 0. So 2 plus negative 2 is 0. Here is 0. Okay, so there we go. We have this simplified version of our augmented matrix. And based on that, well, clearly we have 3 unknowns to be solved, which is C1, C2, and C3. But from this final look of our augmented matrix, we only have second equations to be considered, and therefore it should come to your mind that we are going to have an infinitely many solutions. So there will be one free variable in this to be part of the solution. Okay, so if you consider this part here, it basically says we have 0 times C1 plus 1 times C1 plus negative 2 C3 is equal to 0. So C2 is equal to 2 times C3. Now, what is C3? Well, I'm just going to let C3 be any alphabet. So C3 can take any value of T. So T here is a real number. So that's the solution for C3. And then, therefore, C2 is equal to 2 times C3. Well, this is actually equal to 2 times T. Okay. Next, what we have is this part here. So here we have 1 times C1 plus 1 times C2 plus 1 times C3 is equal to 0. Therefore, C1 is equal to C3 minus C2. So here we have C3, which is equal to T minus C2 is 2T. T minus 2T. Therefore, this is equal to negative T. Sorry, hang on, I did some mistake here. Hang on. So here we have C1 is negative C3 minus C2. So negative C3 is negative t minus c2 is 2t, so this is negative 3t. Okay, so since what we have is the non-trivial solutions, therefore we can say that the set of vectors here is linearly dependent. Okay, I think that's all for now. Thank you very much for watching, and I'll see you in the next video.